Hello everyone. So this video we're going to discuss about density. Density. So what is density? The density of a material is a measure of how squashed up it is, and a dense object contains more mass than a lighter object of the same size. So suppose you have a sponge which is the same size with a rock. So technically, or obviously, the rock is much heavier than the sponge. So that's actually how you're going to compare the density of objects. And it is defined as the mass per unit volume. With this definition, we can actually get the formula of density, which is equals to mass over volume. Or we have this symbol. This is actually called ρ. R-H-O, rho. It's a Greek symbol. It actually looks like a P, but it's not a P. So it's actually something like that. Equals to mass over volume.
Some of the best opportunities to learn are the moments in which we are perplexed, those moments in which you begin to wonder and question. These moments have happened throughout history and have led to some truly amazing discoveries. Take this story, for example. There once was a fellow named Archimedes. He was born in 287 BC in the city of Syracuse in Sicily. He was a Greek mathematician, physicist, engineer, inventor, and astronomer. One day, Archimedes was summoned by the king of Sicily to investigate if he had been cheated by a goldsmith. The king said he had given a goldsmith the exact amount of gold needed to make a crown. However, when the crown was ready, the king suspected that the goldsmith cheated and slipped some silver into the crown, keeping some of the gold for himself. The king asked Archimedes to solve the problem, but there was a catch. He couldn't do any damage to the crown. One day, while taking his bath, Archimedes noticed that the water level in the bathtub rose and overflowed as he immersed himself into the tub. He suddenly realized that how much water was displaced depended on how much of his body was immersed. This discovery excited him so much that he jumped out of the tub and ran through the streets naked, shouting, "Eureka!" which comes from the ancient Greek meaning, "I've found it!" What did he find? Well, he found a way to solve the king's problem. You see, Archimedes needed to check the crown's density to see if it was the same as the density of pure gold. Density is a measure of an object's mass divided by its volume. Pure gold is very dense, while silver is less dense. So if there was silver in the crown, it would be less dense than if it were made of pure gold. But no matter what it was made of, the crown would be the same shape, which means the same volume. So if Archimedes could measure the mass of the crown first, and then measure its volume, he could find out how dense it was. But it is not easy to measure a crown's volume. It has an irregular shape that's different from a simple box or ball. You can't measure its sides and multiply like you might for other shapes. The solution, Archimedes realized, was to give the crown a bath. By placing it in water and seeing how much water was displaced, he could measure the volume. Then he'd calculate the density of the crown. If the crown was less dense than pure gold, then the goldsmith most definitely cheated the king. When Archimedes went back to the king and did his test, the story says, he found that the goldsmith had indeed cheated the king and slipped some silver in. These days, using the way an object displaces water to measure volume is called Archimedes' principle. The next time you take a bath, you can see Archimedes' principle in action. And maybe you'll have a genius idea of your own.
Okay, so that's how Archimedes discovered the density of different types of object. So he submerged the gold into the water and take note the difference on the change of water levels on the tub or any container. So what is specific gravity? It is actually the ratio of density of a substance to the density of the standards. So the standards are the calculated amount of density for each pure substance. You will actually see the substances later. Usually water for liquid or solid. So the ratio for water and solid, water for liquid and solid. So that's how you're going to relate it. And air, the density of air for gases. Okay, maybe carbon dioxide or nitrogen oxide, something like that, or nitrogen gas. Here's another video for density of different substances and objects.
Bearded Science Guy here, and today I'm going to show you how to make a 7-layer density column. Start with an empty glass vase, and begin pouring honey into the very bottom of the vase. Honey has the greatest density of any of the fluids we'll be using, so it'll make our base layer. Next, begin pouring corn syrup on top of the honey. Corn syrup is usually clear when you purchase it in the store, but mixing it with a little bit of food coloring can give it a bright, vibrant color. Next, we'll be using Dawn dish soap. It's important to avoid hitting the sides of your container when pouring the first few layers. The next layer is water dyed with food coloring. Instead of pouring it in the center of the previous layer, use a turkey baster to drip it down the side of the container. The same technique can be used for the next layer, which is vegetable oil. After that, add 91% isopropyl alcohol mixed with a little bit of food coloring for your second to last layer. Finally, cap off your density column with lamp oil. Now, food coloring won't work with lamp oil because of its non-polar nature, so make sure to get some with coloration already added. Now that you have your density column already created, you can begin testing the density of objects by dropping them in and seeing where they end up. I started this process by testing a metal screw, which dropped all the way to the bottom of the honey layer. A grape tomato, on the other hand, dropped into the bottom of the Dawn dish soap layer. A plastic bottle cap came to rest on the top of the vegetable oil layer, whereas a ping pong ball rested on the surface of the entire density column. As you go from top to bottom, the layers become more and more dense, preventing them from mixing together.
Okay, so that's how density works in different substances. So density of a regular shaped object. So these are actually the standards of density. So this column is for grams per centimeters cube, and this column is grams per meter cube. So take note, grams here is the mass, and centimeter cube is a unit of volume. Okay, so of course, meter is actually greater than centimeter. So as you can see on the amount here that we have in our table. So first, vacuum, we have 0, of course, because usually in vacuum there would be no weight or no mass to be able to measure. And next is helium gas, air, petroleum. So these are all the standards. So as we have mentioned earlier about specific gravity, so this is actually the standard for gases, and we have water for solid and liquid. Okay, so example for calculating our density. A brick has a dimensions of 20 centimeter by, or this x can be also pronounced as or called as by. So instead of 20 centimeters x, you can actually say it, or you should say it as 20 centimeters by 9 centimeters by 6.5 centimeters. Okay, so with a given weight of 2 22.2 newtons. So you're asked to find the density of the brick. So solution. First, you need to solve the mass of the brick, okay? Because we are given with the weight. So solving for the mass, we need the formula mass equals to weight over the gravity. Gravity is the gravitational field strength of the Earth. Okay, so that would be equal to the weight, which is 22.2, and then the gravitational field strength, which is 10. Okay, the exact amount of gravitational field strength is 9.81. Okay, for this we'll just use 10. Okay, so after that, do the calculation. That would be equal to 22, or rather 222 kilograms. But we're going to use grams in this matter. So we're going to use grams in this matter. So we'll convert kilograms to grams. So that would become 2,220 grams. Oh, okay. Then the second solution is we need to solve for the volume with the given. So the given is this one, 20 by 9 by 6.5. So the volume is this one. So you just need to multiply these values. That would give us 1,100 centimeters cube. Okay, because there are actually 3 centimeters here. So that's why when you're going to multiply this one, we will have the 3 at the top. Okay, next one is the solving for the density with our given. So the given our volume, we already solved for a volume and the mass. Then we can actually solve for our density. So density, or the raw, equals the mass over volume. We already have our volume, we have already our mass. Okay, so mass and volume. So just need to substitute that here in our formula. So then you will have 2,220 grams and then 1,170 centimeters cube. So our answer, our density is 1.9 grams per centimeters cube. Okay, so that actually concludes our discussion on density. So if you have any questions regarding this topic, please leave a comment below and enjoy the rest of your day.